have a couple of different learning goals today. The first one is going to be, we're going to be solving equations that contain fraction coefficients. So remember, what is a coefficient again? What am I talking about when I say we have a fraction coefficient? Where would we find that fraction if it's a coefficient? Where will it be? Oh dear. New week. Don't remember what we did last week, huh? Or the week before. Maybe even the week before. Coefficient. Come on, let's come up with it. What's a coefficient? Okay, you guys better start digging in some old notes then, huh? Sammy? The number x is being multiplied by. So the coefficient, let's get that planted here, let's remember it. The coefficient is what class? The number x is being multiplied by. So the number that x is being multiplied by is called a coefficient. Well, today we're going to deal with what do we do when we have those coefficients are fractions, okay? So let's have a little reminder of what we have to do. And it says to get a 1x, what would we have to multiply by to get a 1 if we have a fraction? How do you get a 1 when you're multiplying and you have a fraction involved? Danny? Multiply by the reciprocal. So we're going to multiply by the reciprocal. Because we want to create a 1x. So that's going to have to be how we're going to deal with having a fraction coefficient. Okay, so we're going to practice a couple of these types of problems, and then we'll go on to our other learning goals. So our first one is we're supposed to solve the equation 20 equals 1/4 x. What's our coefficient? Caden? What's our coefficient right now in the equation? 1/4. Okay. Is that equation ready to solve? It's got to be our first question. Is it ready to solve? Is there anything we can do to it before we do something to both sides for the solving process? Is there anything we can do first? No, it's 20 on one side, 1/4 x on the other. There's no getting ready in this one. So we're ready to just say, okay, I'm going to do the same thing to both sides. Well, because x is being multiplied by 1/4, we are going to multiply by the reciprocal of that. What's the reciprocal of 1/4? 4/1. So we're going to take 4/1 times 1/4 x. And I'm just going to start on that side because that's the side that we look at where the x is and say, what do we have to do? Well, we have to get a 1 instead of a 1/4 x, so we're going to multiply by the reciprocal. If we do that on one side, we have to go do it on the other side. And I want to see it done down on the next line, not beside it up there. Do it down on the next lines. Now, we can make 20 into a fraction by putting it over what? 1. So since 4/1 is a fraction, we'll make 20 into a fraction also. Okay, so what is 4 times 20? What's 4 times 20 plus? 80. So we have an 80. Do we need that 1 that's underneath? No. So 80 equals x. The goal, what happens here is when we take this 4/1 times this 1/4, what does that become again? 1. So we have a 1x. So we just have our x. So we are going to say that the solution is x equals 80. We'll just write it going the other direction. Okay, now we'll do a check problem, like we always do when we solve equations, except for word problems. We do a kind of like a reasonable check. So 20 equals 1/4 times 80. So we need to do what with that 80? Put it over 1 so that we can multiply on that side. So the 20 is going to stay 20. And 1 times 80 upstairs is what, class? 80. And 4 times 1 downstairs is 4. So this is really saying how many 4s can you take out of 80? Or in other words, it's saying what's 80 divided by 4? It's 20. Is it because we want it to be 20 or because it is? Because it actually is. There are 4 20s in an 80. So we say we must have a good solution. Okay, questions? Okay, first question we always ask ourselves when we're solving an equation as we move on to number 2 is the equation ready to solve? Is there anything I need to do that I don't have to do on both sides? So you think there's something I need to do to get it ready? Sierra, what would I need to do to get this? Add the opposite. Yeah, that's one of the things we do because it has subtraction. So 2/3 x plus negative 34 equals 40. Anything else we need to do to get it ready? No? Okay. Then we're ready to solve it, you're saying? Okay, then what should we do first? Okay? Yep. Add a positive 34 to each side. Add the opposite of that negative 34. And on the left side of the equation, that's going to zero those guys out, isn't it? We're going to have a 2/3 x left equal to what? 74. Okay. Okay, now what am I going to do? What do you think we should try next? Harley?
Do the reciprocal.
Okay, what is the reciprocal of 2/3? 3/2. So what do we do with that reciprocal? Times it. We multiply with it. So 3/2 times 2/3 x. And we take 3/2 times the other side also. What are we going to do with that 74? Put it over 1. Okay. What happens on the left side? What do we have? Just x. This took care of getting a 1x for us. And now we got to do 74 times 3 upstairs. What is that? I get 222. You do also? Okay. And what do we have downstairs? 2. Okay, we're going to divide 222 by 2. What is it? 111. 1. Okay, we think the solution is 111. But we're not moving on until we check it, right? And make sure. Okay, so I've written the equation for us already. So we are going to first, though, rewrite it as add the opposite, like we always do. Let me get that subtraction sign showing better. Or that negative sign, I mean. Now we'll substitute in our solution of 111 and put it over 1, right? Since it's going to get multiplied by a fraction. And you remember when we're checking, it's always a good idea to box what we substituted because that means we're going to probably have to do something with that first before we move on. But we'll bring down the rest of the equation. Okay, 2 times 111. 222. 3 times 1. 3. Okay. Those other guys are just having a merry old time coming along. know what I'm thinking we should do? We have to divide 222 by 3. But I'm going to go right back over here to where we multiplied earlier and look at, I say, if I multiply 74 by 3, I get 222. So what do you suppose 222 divided by 3 is? 74, yeah. And now we have 74 plus negative 34. What is that? 40. Okay, convince me why it's 40. Okay. Yeah, because we're really subtracting 34 from 74, and 74 take away 34 is 40. Even though we want it to be 40, we have to make sure it really is 40 before we can say it checks. So kind of a big solution that checked out. Questions? So we've already learned a whole bunch of stuff about getting equations ready to solve, solving them. The only thing kind of different today is what? What's the difference today? What's the learning goal? I can solve equations with fraction coefficients, so that's what's different today. Our coefficient is a fraction. Otherwise, everything else you've already learned. So don't, let this one new little thing throw out all the other stuff, right? Okay, let's go to the back side for our other learning goal. And it says we're solving complex rate problems again. So our word problems are still hanging around. Solving rate problems. I want you to circle this. Rates that start at different times, but going the same distance. So instead of them combining their distances together, we are going to say they're going the same distance. So let's just kind of break this apart. Levi and Jack are getting ready to run a lap in PE class. Levi is much faster than Jack. He says to Jack, I'll give you a 10-second head start. So Jack starts running 3 yards per second. Levi waits for 10 seconds and then starts, because he told me to give him that 10-second head start, right? He is running 4 yards per second, because remember, he's faster. How long will it take Levi to catch up to Jack? So let's kind of get a picture of what's going on here. We're in the gymnasium. Jack starts running. How long does he run for? How long? 10 seconds, okay. So he's, let's pretend that he makes it all the way up to the door here, okay? Where's Levi at right now? He's still back there where Jack started, isn't he? He hasn't done any running yet. And it wants to know, how long will it take for Levi to catch Jack? Well, Jack's not going to stand here and wait for Levi, is he? He's going to keep going. And Levi's going to take off after that 10 seconds, and he's going to try and catch up with Jack. When he catches up with them, what will be true? Will Jack have run more than Levi, or will Levi have run more than Jack, or will they have run the same distance? They will have run the same distance. They started at the same place in the gym. Jack just got to have a head start. And Levi is going to catch up with him, so wherever he catches up with him at, if it's halfway around the gym or 3/4 of the way around the gym, wherever it is, they will have run the same distance, okay? So, what can we cross out here? We got a lot of stuff going on here. What can we cross out? Tyler?
Levi and Jack are getting ready to run 5 feet.
Yeah, it's kind of nice to know where they're at and, what's happening, but it's not going to help us necessarily with our equation. What else can we maybe cross out? Even though it's important to the problem, but Sam?
Levi's much faster than Jack.
Yeah, Levi is much faster than Jack. Okay. What do you think is wait?
Cross out the dialogue.
The dialogue. He says to Jack, I'll give you a 10-second head start. Okay. Because do they refer to that 10 seconds somewhere else? And is that going to be important? Yeah, it is going to be important, but they refer to it somewhere else, don't they? Okay, so now what? Do we have anything else you want to cross out, or should we start underlining and circling? Let's circle first. How long will it take to catch up? I might want to just kind of like underline that part. How long to catch up to Jack? Okay. How fast is Jack running?
3 yards.
Okay. So Jack is running 3 yards per second. How fast is Levi running? 4 yards per second. Levi is running 4 yards per second. And is this waits 10 seconds kind of going to be important somewhere along the line here? Who's running during that 10 seconds? Jack. So you know what? This 10 seconds right here, we're going to put that right here. We're going to write, this is Jack. He's already running for 10 seconds. Okay. So, you know, the first thing we always do is we say, this is a rate problem, so we set up our, what's the first thing we always do in a rate problem? Yeah, our fraction, what is the rate? What's going on? So what's the rate in this one?
Seconds and yards.
Yards per second. So that rate needs to be multiplied by what? Seconds. We want those seconds to get canceled away because we can't have two labels going on when we're actually working with it. So we have the seconds will cancel away. So whatever our multiplications are, they represent the number of yards. And what's the other thing we do right away in the beginning? We say x is, and since it says how long, it's going to be the number of seconds. Those are two really important things to start with. Now we're going to draw a diagram. This is going to be a straight shot. We're not, going to, even though we know that they're going to have to turn some corners, we're going to make it look like they're just running a straight task. Okay, so this is, let's start with Jack. Okay, this is their starting point right here. Jack takes off and he runs for how long? 10 seconds. This is Jack running for 10 seconds. Okay. And what's going on after that 10 seconds?
Starts running.
Levi starts running.
Levi starts running, doesn't he? Mm-hmm. So this is Jack running for 10 seconds, and then Jack is going to run. Does he keep running? Yes, he keeps running. And that's going to be our, we don't know how much longer, right? Does Levi start at the same spot? Yeah, he starts at the beginning. And how long does Levi run? And where does he stop? No, Levi runs till he catches up to Jack. And how long does he run? Is he running during that 10 seconds? No, so he's only going to run the X seconds, right? So is this an addition problem? What do you think? Are they running the same distance? Same means equals, doesn't it? So here's what we're gonna do. We're going to say, let's put this little note there. They will be running the same distance. And our picture shows that. This is where they catch up, is right here. That's where he catches it. They're gonna be running the same distance. So let's look. Our multiplication problem says if you take the rate times the number of seconds, that gives you how many yards they have run. So since they're both going to run the same number of yards, don't we need Jack's yards to equal Levi's yards? Isn't that what we need? They're running the same distance. We're not supposed to add them together this time. So how are we going to get the number of yards that Jack runs? Remember, he's got two things going on. He got a head start. What would we do for the first part of his leg? Look at what it says up here. Take the rate times the number of seconds, and that will give you how many yards was run. What do you think we could do? How fast is Jack running? 3 yards per second. How many seconds does he run the first leg? 10 seconds. Oh, well, that's kind of, we got to remember that he's got that going on. So we have 3 times 10. That's that first part right here. That's this. This part right here, we just did that. Plus, he runs until Levi catches him. He's still running. What are we going to write for the next part? I'm sorry, what? Say it louder.
4 times 10.
No, Jack is still running. He didn't speed up. 3 times x. Yeah. There's the other part. So the first part, we know how fast he's running. He's running for 10 seconds. The second part of his running, we don't know how long it took for Levi to catch up, but we know that he's still running 3 yards per second. And now we can set it equal to how far Levi has to run. So again, if you take the rate times the number of seconds, you get the distance. So what are we going to do, Harley? Levi is 4 times x because he's running 4 yards per second for x number of seconds. So we have our equation. Is it ready to solve? Think we can do something else yet to get it ready? What's 3 times 10? 30. I think that should be done. What's 3 times x? What's 4 times x? 4x. Okay. No subtraction going on. Any more getting ready to do? Remember, getting ready is you're not doing the same thing on both sides. You're just, we're ready? Okay, now let's go. What are we going to do? No.
Add -3 on each side.
-3 what?
X.
Yeah, we got x's on both sides. We only want them on one side. So when we have x's on both sides, we're going to deal with those guys first. So we need to zero out some x's. Let's zero out these guys. So now that they have canceled each other out, we have the 30. And what do we have on the other side? an x. 4x plus negative 3, that's a 1x, isn't it? Yeah. So x equals what? 30. We don't even have to do a division problem, do we? If there had been a coefficient other than 1 there, we would have had to divide, but since there wasn't. Okay, and that's 30 what?
Second.
Go back up to our x. Is it seconds or yards? Seconds. Okay, so we're ready to write our, what? Sentence. It will take who? Levi. The question was, how long will it take Levi to catch Jack? So it will take Levi 30 seconds to what? To catch up with Jack. Okay, now for a piece of candy. Oh, so quickly when I say that. How far did they run? Ikea?
Jack ran 90 yards and Levi ran 120 yards.
What do you think, class? Think she's right? Why not, Sylvia?
Well, they should be running the same distance.
Yeah, they should be running the same distance, shouldn't they? Hmm. Should be running the same distance, so one can't run 90 and the other 120. Danny?
Around the same distance, but one's like ahead, like faster than the other.
Okay, one is faster than the other one. That was why he was such a generous friend and gave him a head start. But does head start mean, in this case, it was a 10-second head start, not a so many yards head start, was it? So did they still start at the same place? It's just that Jack took off before Levi did. So they're still going the same distance. How far is that? One side of the equation has to equal the other side of the equation. Both sides are representing distance. One side of the equation has to equal the other side of the equation. One side is equaling distance, so is the other side equaling distance. I can't give away my candy. Give up?
It's still working.
Some of you are working, some of you are thinking without working. How far away? 105? What do you think, class? Do you think he's right? I think you might want to challenge that.
Just tell us already.
Then I get the candy, huh? Okay, well, while you're still trying very quickly, I'll see what I want. Oh, I think I'll have some smarts. Okay. The answer is, they will each, oh, Sylvia.
120.
Yeah, it's 120.
Good job, Sylvia. Okay, you got my Smarties or you want to pick out your own candy? No, I don't get them. You pick out your own? Okay, 120 yards. Sylvia, while you're at it, will you tell them how you got 120?
Well,
Oh, let me get the highlighter up. If you wanna write on here, you're more than welcome to. What did you do? Do you want me to give you just some white space? Sure, go grab your paper, absolutely. This is Jack she's writing about right now. Did anybody do a check problem for this one? I kind of think that's what Sylvia's gonna be doing here in just a little bit. I think she might be doing a check problem. And when you're, one of the ways to figure out the answer would be maybe to substitute it back in, right? Is that what you did, Harley?
Mhm.
Did you substitute it back into the equation
Yeah, X.
for x? Because what was x again, class? 30 seconds. So if you take 30 seconds times the rate, that should give you how many yards they ran, correct? And remember, one side is representing Jack's distance, the other side is representing Levi's distance, and they are the same. Why, looky what happened when Sylvia did a check problem. She got 120 equals 120, which the distance is 120 yards. Good job. Okay, well, I thought I'd be giving away all kinds of candy, you'd all get it.